So I believe he was a French mathematician named L'Hopital. Okay, you don't. It's not. Some people say Little Hospital. No, it's not. Okay, L Prime Hospital. No, sorry, L'Hopital. Okay, and he started to kind of work on some of these indeterminate forms that we get in mathematics. And the problem is that the word calculus means the ability to calculate the infinitely large and the infinitely small. And so what happens if we get infinity divided by infinity, or infinity or zero divided by zero? So the limit as x approaches a of f of x over g of x, if you get infinity over infinity, or you get zero over zero, that's referred to as an indeterminate form. So L'Hopital's rule does not apply unless you start with that. Are we clear? Once you start with that, here's how you can evaluate it. Take the derivative of the top, divided by the derivative of the bottom. No. And that's what you don't want to do. And that's a mistake that sometimes people make. They're like, okay, so I need to use the quotient rule. No, you just focus on the top, take the derivative, focus on the bottom, take the derivative. For example, look at something we already know how to simplify, okay? Pretend you don't know that you know how to cross off the x's, all right? If we were to plug in the infinity to the top, you would get infinity. Plug in infinity to the bottom, you get infinity, right? That's an indeterminate form. Think about the graph. The graph of 3x is a line, right? But x squared is a parabola, okay? So you can see that for a while, the line is bigger than the parabola, right? It's on top. But eventually, the parabola overtakes the line, and the parabola is greater than the line for the rest of the time, correct? And if we divide them, we're really looking for that ratio of difference between the two. So, for example, the line has a height of this, but the parabola has a height of this. Okay, and if you divide those, you can see you're going to get a positive number. Well, what happens as you move further out? Okay, here the line is this height, but the parabola is going to have a height of like that. So what's going to happen to them as you divide them? Yeah, they're going to continue to get larger and larger and larger. So we could apply L'Hopital's rule here and say this is the limit as x goes to infinity of, what's the derivative of x squared? What's the derivative of 3x? Now, plug in infinity. You get 2 times a very large number on top divided by 3. That's not infinity over infinity. That's not 0 divided by 0. It is simply what, Andrew? Yeah. So L'Hopital's rule helps us to be able to determine these indeterminate forms. Let's look at an example that we wouldn't know how to do yet. Limit as x goes to 1 of natural log of x divided by 1 minus x. Now, some of you don't remember, but do you know what the natural log of 1 is? That means natural log of 1 means e to what power is 1? E to what power is 1? 0. If you don't know, you can type natural log of 1 on your calculator. It'll come up with 0. Okay. Yeah. And then what do you get in the denominator? If I get 0 over 0, that's an indeterminate form. No, you don't have to. You can just start using L'Hopital's rule. If you don't come up with 0 over 0 and infinity over infinity, you can't use L'Hopital's rule. So what's the derivative of the top? 1 over x. Divided by, what's the derivative of the bottom? Isn't that just negative 1 over x? Well, now let's try plugging in 1. What do you get? That's the limit. We got some sniffles going on here, folks. People got colds? Okay. Hope you feel better. All right. Let's plug in a very large number. The limit as x goes infinity of e to the x will give you over. Hey, I don't know how to do that. It's indeterminate form. Let's use L'Hopital's rule. Limit as x goes to infinity of derivative of the top, derivative of the bottom. Plug in a very large number. Top goes to, bottom goes to. Hey, I still have an indeterminate form. What should I do? Derivative of the top, derivative of the bottom. So you get a very large number divided by 2, which would be infinity. Could happen. An n. A very large number. All right. Okay. I understand that sometimes you may not know, like, you're like, okay, well, if I plug in infinity for natural log, what will I get? Hopefully you can remember some of these graphs. You might have to look at your calculator, bring some to mind for you, but e to the x looks like that. Natural log of x is the inverse, so it looks like that. So which one goes to infinity more quickly, e to the x or natural log? But natural log still goes to infinity, doesn't it? Okay, the other one, like the cubed root of x, remember that from last year, that looks like this, okay? And so that's kind of like natural log in its behavior. It does head off towards infinity, not very quickly. We'll kind of find out which one gets there first, you know, if it's going to be natural log or e to the x, or x to the 1/3. So let's plug in infinity. Natural log of a very large number will give you, yep. And the cubed root will still give you very large number. That's an indeterminate form, so I take the derivative of the top and the bottom in accordance with L'Hopital's rule. How do I take the derivative of natural log of 2x? Chain rule, outside is natural log of u, inside 2x. Derivative of 2x, 2. Derivative of natural log of u, 2 over 2x, which is, so I get 1 over x in the numerator. And then the denominator, I have x to the 1/3. What's the derivative of x to the 1/3? Yep. Okay, I should probably simplify that, right? So what are you going to do? So 1 over x times 3 to the x, or 3x to the 2/3 over 1. So I'm going to end up with a 3 in the numerator. Well, I have an x in the numerator or denominator? Denominator, Carter? It would, but you'd also end up with 1 over 0 here. Or 1 over a very large number of 0. You still end up with 0 over 0. We're trying to work through that. So x to what power in the denominator? 1/3. Let's plug in a very large number now. What do you get in the numerator? 3 in the denominator, very large number. 3 over a very large number will give you 0. So notice what happened. Here you had infinity over infinity, and you came up with infinity. Here you had infinity over infinity, and you came up with 0. Okay, it could be any value at all. Look at number 5. Plug in 1. What's the natural log of 1? 0 squared, 0. Over, what is cosine of pi? It's negative 1. No need to use L'Hopital's rule, right? That's it. How about this one? Sine of pi, 0, divided by 1 minus cosine of x. So cosine of pi is negative 1, 1 minus negative 1, negative 2. Is that indeterminate? No, so the answer would be 0. Oh yeah, positive 2. Yeah. Still 0. But what if instead of 1 minus cosine, what if it was 1 plus cosine of x? So then it would be 0 over 0, and I would use what? L'Hopital's rule. And I would have the limit as x goes to pi of, what's the derivative of the top? Cosine. What's the derivative of the bottom? Instead of rewriting a whole new example, I'm just doing 2 of them. Nope. So, derivative of positive cosine is negative sine of x. If we plug in pi in this situation, we get cosine of pi is negative 1. And what is the sine of pi? We don't know. The limit could be does not exist. The limit could be positive infinity. The limit could be negative infinity. And we don't know unless we really investigate a little bit further. No. I can't use L'Hopital's rule. It's out now because I don't have an indeterminate form. But here's what I am going to do. There's a couple ways to approach this. I'm going to choose the easier way first. What's cosine divided by sine? Cotangent. So I want to look at the graph of cotangent of x, negative cotangent of x, as x goes to pi. Now, the very first part of the year, we learned to do these limits, didn't we? By looking at our calculator. This one, you got to look at your calculator and consider the graph. So you can either take that out or follow along with mine. So I'm going to go to y equals, and how do I type in negative cotangent? Negative 1 divided by tangent. I'll zoom standard and see what I get. Remember those kind of graphs? Okay, so we're looking at pi, right, or 3.14. So I'm going to zoom as a box, and I'm going to try to kind of isolate around that region of 3.14. So I'll start my x value around right about there, and I'll go down, and then I'll move. Okay, I'll move past 3.14 over to right about there. Okay, so I definitely see 3.14, correct? You all okay with that? All right. By the way, is this a one-sided limit or a two-sided limit? It's a two-sided limit, right? What's the limit as I approach pi from the left? Infinity. What's the limit as I approach pi from the right? Negative infinity. So if it's different from the right than it is from the left, it does not exist. Yes. That's the vertical asymptote. I know you all remember your cotangent graphs from last year, right? We'll finish example 7 before lunch. Example 8 we'll have to look at after lunch. As we look at example 7, we start by plugging in 1. What do you get? What is 0 over 0? We don't know. It's an indeterminate form. Invoke L'Hopital's rule. We take the derivative of the top. 70x to the over 24x cubed. Now let's plug in 1. What do you get? Which is 35 over 12? You're not dumb. That's the limit. I'm going to hand out your assignment as well as your study guide at the same time because this problem is going to take us about 4 or 5 minutes to get through. We'll look at it when we get back. Sam demands evidence. That's who he is. Give me evidence. Take it from the Batman. All right, sorry about this. Instead of X, it should be T, but I'm a bad teacher. So, okay. Does it really? Oh. All right. Looks like I made a change for something and forgot to do for something else. Okay, here we go. So example 8, limit as t goes to 0 of e to the t minus 1 over t cubed. Let's start by plugging in 0. Because e to the 0 is minus 1 is over 0. Hey, what is 0 over 0? That's a really good question. We don't know. It's an indeterminate form. Go L'Hopital. Derivative of the top. Derivative of the bottom. Plug in 0, you get? No. You have 1 over 0. Is that an indeterminate form? Okay. This is where you have to be really careful, you guys. You got to be really careful and recognize that 1 over 0, when you're doing a limit, it could be does not exist. It could be negative infinity. It could be positive infinity. We don't really know. We've got to think about it. Right. So, look at how we're going to figure this out. Okay, this is really critical thinking, but it's something that we want to give a little bit of thought and attention towards. Okay, what does 3t squared look like? Everybody okay with that? What does e to the t look like? What does it pass through? Passes through 0, 1. Okay. Is this a two-sided limit or a one-sided limit? Two-sided. Let's consider the left. Let's consider the right. We need to look at the blue function and the black function. As I approach 0 from the right, what does the blue function approach? 1. As I approach 0 from the right for the parabola, what do I approach? 0. But we don't know what 1 over 0 is. So, what are some of the numbers that you would get to before you get to the 0? Yeah, some very, very small numbers, correct? If you take 1 and they're positive, correct? 1 divided by a really, really small positive number is going to turn into a really big number. Agree? So this side is going towards infinity. Look at the left side. The blue function, okay? As I trend towards 0, what does the function trend towards? Okay? Now, I'm going to have x approach 0 from the left side. What is the function approach? 0. But are the values positive or negative? No, no, no. The x values are coming from the negative, but the outputs, are the outputs positive or negative? They are positive. So you're going to get some of those same very small values, correct? So you're going to approach. Is it the same from the left as it is from the right? So the limit is, that required a little bit more critical thinking, didn't it? I would say that you should know how to do it. If it's on the test, that would be one of the harder questions I would ask.